Hello friends, a very warm welcome to Sarat Chandra IAS Academy, where your dreams are our mission. This is Yatharth here, and today we'll be talking about mountains of the world. This is a topic from geography, world geography, and oftentimes question can be seen here in prelims. So this is a static topic and a permanent one, in fact. So you need to read it every time you are taking the exam. So let us finish it once and for all. So what we'll be seeing here, we'll be seeing the both the things, the basics, and then we'll be reading about the most important mountain chains or mountains of the world. We are dealing here with the world mountains, not the Indian. Indian we'll deal with in a different lecture. All right, and we'll be reading some important points about them as per UPSC. All right. So let us first of all see the most important mountain chains or their locations. So when we come to the Americas, USA, there are two important chains. One are the Rockies. These are the Rocky Mountains. And one are the Appalachian. These ones. All right. The Rocky basically continue as the Andes. These are the Andes. All right. And when we go down towards the Antarctica, then we can see further continuation of this mountain range. So Andes of the Antarctica we can see. All right. Then when we come to the African subcontinent, then there is the major mountain range known as the Atlas Mountains. All right, this is the major mountain range here. And then there is Drakensberg in the South Africa. Now when we move further towards Australia, so on the eastern part, southeastern part of the Australia, near the island of Tasmania, there is the Great Dividing Range. So we'll see how it was formed. About India, we already know there is a very old mountain range here, the oldest mountain of the world, the Aravalli Range. And then there are further ranges of the Western Ghat and the Eastern Ghat. There are Himalayas here, very big range, the youngest mountains. Then there are Arakan in the Myanmar side, and further continuation in the Andaman and Nicobar side. There are many small mountains here which we are not going to read so much, but the Altai Mountains are very famous one because they are located at a tri-junction of the Russia, China, Mongolia, etc. There are Hindu Kush Mountains which we are not reading right now. Alright, one more important mountains range are the Ural Range. This divides basically the Europe and the Russia. Then one more major mountain chain is the Alps. This is located on the border of France and Germany. Alright, so a very important one. So this is also very famous because of the Tour de France, which is a cycling race which happens in this area. Then there are a few mountains which are not very major towards the Russian side. Alright, so let us now begin with the basics related to the mountain system. What are mountains and what are mountain ranges and their classification. So the classification is very important for us to know about. So the first question that arises is what is a mountain? So mountain is basically a big landform that protrudes from the earth. Alright, and it is different from hills. In the classification that hills are smaller, basically mountain is larger or bigger. So as we can see that mountains are essentially conical shaped. Alright, so it is either bigger in diameter or bigger in the height. Alright, so a mountain is a landform that sharply protrudes over its surrounding and has notable local relief, steep slopes, and a tiny peak region. Nearly 27% of the world's land surface is covered by mountains, and 80% of the planet's fresh surface water comes from the mountains. So this is some important data which you can write in your answer or remember. Such data is very important to note down. Alright, and this can help you in your introduction writing a lot. It can also help you in, let's say, GS3. If you are talking about climate change, glaciers. In the last lecture, we talked about glaciers also. So there also I told you about the mountains and how a mountain differ from the glacier. So a glacier can itself be as big or even bigger than any mountain. Alright, but glaciers are composed entirely of the ice. And mountains are composed of rocks. Various different type of rocks. So we already know various different type of rocks, sedimentary, metamorphic, and so on. So no need to read that here. So let us see classification as per origin. Just a second. Alright. So there can be block mountains, there can be fold mountains, then there can be dome mountains, mountains of accumulations. Accumulations basically mean to accumulate over one over other. Alright, to collect one over other. Then there are circum-erosional or relict mountains. The most important mountains are of two types. One are block mountains and one are fold mountains. So let us see about them. So the block mountains are those formed by the internal or endogenic earth movements which cause the force of tension and faulting. Alright, so we are talking about the faulting here, some sort of fault. The downlifting or uplifting of land in between two parallel faults result in the formation of block mountains. So this is the important point. Just a second. This is the important point that we need to see, that there are two parallel faults. So now this is a block. Alright, now this block has two places to go. Either it will rise or it will fall after the fault is there. Alright, so that there can be a downlifting or uplifting of land. So if there is uplifting of land, then it will become the mountain itself, or otherwise it will become a valley. Alright, these will rise. So there can be a rift valley in between. So block mountain was also called a horst, and the rift valley formed as a result of faulting is called as graben. So please remember these two terms, they are very important. Higher blocks are referred to as horsts and troughs as grabens. Example include the Rela European mountain range, Satpura range. This is very important. It came into the exam in prelims. Just a second. So it came into the prelims this time, 2023. There is Sierra Nevada range in the USA and the Vindhya range. Alright, this also was in the among the options in prelims. So these are basically block mountains. So when there is block mountain, it will create a rift valley, and more often than not, there will be a river flowing through this rift valley over time. So there are many important rivers in India which flow through such rift valley. You can classify and name them accordingly. Moving forward, here we can see the diagram that whenever there is a parallel fault, let's say this is the fault A and B. Just a second. So these are the fault lines. Alright, so these are the fault lines, and then there is a downshifting, and now here is a upshifting. So this becomes the mountain itself, or this becomes a ridge valley, and these become the mountain. Alright, so these are the mechanism of the formation of block mountains. Now we go further towards the fold mountains. So large scale tectonic plate collisions. So here we are looking towards the tectonic movements. Alright, not as such fault making of the endogenic movement. We are looking at the tectonic plate collisions causing folding and subduction of land. Subductions means to go below or beneath, which leads to the formation of fold mountains. So these are formed due to the forces of compression arising from endogenic or internal forces. So synclines here are the troughs. Just a second. So syncline here are the troughs, and anticlines crest are the part of the fold mountain. So this will be the crest. Alright, so folding is basically, you can see like this. You can see like this. So this part is known as the anticline. And this part is known as the syncline. This part is known as the crest. And this part is known as the fro. Okay. Let's move forward and see some examples. So the Himalayas, we already know where they are, very famous. The Rockies, the Andes, the Balkan, Jura Mountains. Okay, one thing is noticeable here, that as we are talking about the tectonic plate collisions, so the mountains which are often located where the tectonic plates could have collided, such as the ends of the continents. So let's take the US's end. Here we see the Rocky Mountains. Let's take the Southern Americas. Here we see the Andes. Let's see the Indian plate collision with the Eurasian plate. So here we see the Himalayas. Alright. So Balkans, Zagros are the most prominent fold mountains of the world. Those mountains which are located inside the continent, they are mostly block type of mountains. So rocks that formed under intense pressure. So of course, if there is compression, there has to be pressure, and low temperature, such as sedimentary and metamorphic rocks, make up majority of the fold mountains. Mainly, fold mountains develop when a layer of ductile minerals like salt is underlain. Alright, let us see some folding. So here you can see the sea. There are various different mechanisms. However, all the mechanisms of the fold mountains formation, they have three conditions. One, some sort of ductile material, such as sedimentary rocks, rocks formed under high pressure and low temperature. Alright, there can be a salt layer underneath for good movement, and there has to be compression. Alright, so Himalayas you can take as an example of the folding mountains. So Himalayas, Rockies, so they are the example of folding mountains. Let us now come towards the mountain dome. So these are created when the top sedimentary rock layers are forced upward. Alright, we are not talking about the downward, but the upward by the hot molten material, magma. So these are related towards to the volcanoes. So these consequently take the shape of a dome. Magma rarely reaches the Earth's surface here, unlike a volcano, but they are related to the same physical or biological mechanisms as the volcano. Alright. One more are there, mountain of accumulation, which are volcanic mountains. So accumulation of volcanic material creates volcanoes, sometimes referred to as mountain of accumulation. The thrown out volcanic debris settle in the form of a mountain range around the crater itself. And a flatter cone with a lower elevation and a softer slope results from thin, simple composition lava spreading across a vast area. If the composition is thick and acidic, the result will be a little volcanic cone that protrudes abruptly. Sometimes the lava is sent out along with the ash. So it's not always, but sometimes. And they are little wide, like this, rather than like this. Alright. So Mount Mauna Loa in the Hawaiian island of Hawaii, Mount Popa in the Myanmar, and Fujiyama in Japan are examples of it. You must have heard of the Fuji. It's a volcano mountain. Alright. So these are the type of the volcanic mountains. Alright, this ash cloud and lava will solidify and then create a mountain like this. Alright. There are some circum-erosional relict or residual mountains. So these are the exposed remains of ancient fold mountains caused to denudation. That means a strip of covering. These can also develop from plateaus that have been eroded into hills and valleys by rivers. That means residual. There should be some erosion for the residual mountain formation. There can be found in India on hills like Nilgiri, Palakonda, Parasnath Hill, and Rajmahal Hills, as well as on the mountain like the Aravali, Vindhya, and the Satpura. These are basically residual hills. So Aravali mountain we will read about later. Okay, so further upon erosion, their height have reduced by a lot. They were the highest mountains of the world one time. Alright, now their height is very much reduced because of the erosion. Average height is around 400 meters now. Okay, so not a lot. Let us also see now classification as per the period of origin. So 9 orogenic movements. What is orogenic movements? Were slow movements of the lithospheric plates which help in formation of the mountains. So they have occurred altogether to date. Some of them took place in the Precambrian era between 600 and 3500 million years ago. Alright. The three most recent orogenics are the Caledonian, Hercynian and the Alpine. So when we read about the Alpine, we see the Alps here. Alright, we'll see about these two as well, the Caledonian and the Hercynian. Just remember that there have been 9 major orogenic movements or orogenic movements. Alright, and some of them took place in the Precambrian era. So they have been very, very old, between 600 to 3500 million years ago. Let us just take a brief revision of the periods of the Earth. Alright, so when we see the Eon, it's the largest classification. So we come towards the Archean, the Proterozoic, and the Phanerozoic Eon. But we mostly deal with the eras. Alright, this is what we most talk about. So there have been 3 big eras, that is Paleozoic, Mesozoic and the Cenozoic. The Cenozoic it is itself divided into some periods, Quaternary, Neogene or Paleogene. There have been different epochs also, such as Holocene, Pleistocene, Pliocene, Miocene, Oligocene, Ecocene and Paleocene. Then in the Mesozoic era there were Cretaceous period, Jurassic period, the period of dinosaurs. Alright, Triassic period. And Paleozoic there are Permian era, the Carboniferous era, the Devonian, Silurian, Ordovician and Cambrian. Some of them, the mountain orogenic movements have been Precambrian also. Alright, so 3500 million years ago also some of the orogenic movement have taken place. But most of them have taken place into this Cretaceous Paleogene era, Paleogene period. Alright. Okay. We see this sort of things also. Just the 3 eras. This is Paleozoic, Mesozoic and Cenozoic. Then there is Holocene, Pleistocene, Pliocene. You can read about this. You can take this as a reference because this is most famous when dinosaurs were there. Alright, and further from this you can read, and below this you can learn. Alright, so when we talk about the mountains, some orogenic movements can be seen here. You can see the Atlas mountains, the Alps, their formation. Alright, and furthermore, we come towards, I have created a table here. I'll post this PDF on our Telegram group today only. So do not worry about losing all these notes or anything. It will be very helpful for you. Okay, so let us focus on the orogenic movement. So the Caledonian, first we will get to this, the oldest one. So it was in late Ordovician or early Devonian period. Alright, and the location which influenced was Northern Europe, Greenland, Scandinavia and Scottish Islands. So towards the Arctic mostly. Alright, so formation of the Caledonian mountains, collision of Baltica and Laurentia continents, formation of subduction zone and development of fold and thrust belts. Also it formed the granite intrusions. Then there was Hercynian. It happened in the late Devonian and early Permian period towards the Western Europe, Central Europe, Iberia and North America. So formation of the Hercynian mountains, collision of Laurasia and Gondwana continents, the development of extensive folding and faulting, and formation of the Versican mountains, intrusion of granite and metamorphic rocks. Then we come to the latest one, the Alpine. It happened in the late Cretaceous and present, it's ongoing actually. Took place in the southern Europe, Mediterranean region, Himalayas, Rocky Mountains, etc. So formation of the Alpine orogenic belt, collision of African and Eurasian continents, thrust faulting and folding of sedimentary rocks, formation of the Swiss Alps, Andes and more, earthquake activity along the plate boundaries. Alright, one more important thing that we need to see from here is that it is still going on, the continental drift, let's say Africa, take Africa. So it's supposed to be broken into 2 parts from the Rift Valley. This part will be separated in the future. And from here only, India has been separated earlier, Sri Lanka, Australia. So they were all connected. Alright, so in future also it will break into further parts. So when we come to the pre-Cambrian mountains, the Precambrian era, which lasted for more than 4 billion years, is when these mountains first appeared. And these rocks have been metamorphosed, denuded, and uplifted. As a result, the relics resemble residual mountains. Some examples we'll see. Algoman and the Laurentian mountains are examples of this. When you come to the Precambrian mountains, so these rocks, just a second, there is an error in the PDF, just a repetition. Okay, we'll come to the Caledonian mountains. So massive orogenic activities and associated tectonic movements through the late Silurian and early Devonian periods. So this happened before this, between this time. Just remember the timeline, 430 million years ago to 380 million years ago. And examples are the Appalachians, Aravallis, Mahadev and others. So these are one of the oldest mountain of the world, Appalachians and Aravallis. Alright, so this Caledonian mountains. Alright, let's see the Halcyonian mountains. So what are some examples? The Altai range, Asia's Tian Shan, Black Forest mountains, these are in the Germany. And the Ural mountains. So we'll read about these mountains, Altai, the Aravallis, Ural mountains, we'll read about all them. Alright. So these are mostly in the Europe, this side. The Alpine mountain, this one is the last one. So it happened towards the last movement, orogenic movement. And 8 Alpine nations are included in this: France, Switzerland, Monaco, Italy, Liechtenstein, Australia, Germany and Slovenia. So they are the highest and broadest mountain ranges in all of Europe. These were created by the collision of African and Eurasian tectonic plates of millions of years ago. And extreme shortening brought on this event caused marine sedimentary materials to shove and fold into high peaks like the Matterhorn and Mont Blanc. So this is the highest peak of Germany. There's a pen company also on this name. Alright, you can classify the mountains based on their height also. So low mountains, rough mountains, rugged mountains and high mountains. So high mountains we can see more than 2000 meters, such as Kanchenjunga range, Himalayas, Everest. These are 1500 to 2000, most of the mountains of Western Ghats. So Agasthyamala hills, you can say Nallamali hills and many other rugged mountains. So no need to remember these as such, just a basis of classification. Other classification can be via their location, let's say coastal mountains, alright, inland mountains and oceanic mountains. So some examples can be, coastal mountains can be the fold mountains such as Rocky, Appalachians, Alpine, Western Ghats, Eastern Ghats, alright, Western Ghats, Eastern Ghats, Rocky mountains, Appalachian mountains, Alpine ranges in the Europe. So now you may be able to remember when they were formed, alright, Appalachians, Alpine, in which orogenic movement they were formed. Inland mountains are Black Forest. The most European mountains are inland mountains, which happened in the last Alpine orogenic movement. Alright, the Urals, Aravallis, Himalayas, Satpura. And oceanic mountains, you can see Mount Kia. Volcanic mountains are most oceanic mountains, such as Hawaii, highest peak if measured from the ocean floor, part of the Hawaiian volcanic chain. So Mauna Kea is one of the highest mountain ranges if it's measured from the ocean. Alright, so only some of it is outside. Let's say this much is outside. So Mauna Kea could be the highest one, 9140 meters. So that's a lot. Alright, so this lecture I will end here. In the next lecture, we will talk about the locations of important world mountains. So this is Yatharth here. I hope you liked the lecture and learned a lot. In the next lecture, we will take the part 2 where we'll be reading about more things. Thank you very much. I'll see you in the next lecture.